So the next step, see, this is how I have to do for the recording, right? So the next step is to use our sequence to construct the phylogeny, right? So we come to this website called ngphylogeny.fr from the French government. So we click this a la carte custom workflow. And this, you can do any step you want. You can mix and match everything. So we're going to do two steps here. We'll try to keep it simple. We're going to do the multiple alignment. We're going to use math because math is the quickest algorithm available here. This step you can also do, this is called curation. It makes your alignment a bit cleaner, but it takes a bit longer, so we're going to skip that for now. Okay, but if you want to try, you feel free to. And then this third step is tree inference. This is how you make a tree. There are a couple of different options. The first five are for maximum likelihood, and the last one is for for Bayesian tree. So we're gonna try 5 ML here. So let's try this together. And once you have this, so just select two things and it will create this workflow for you. So what we did before in R is that we just did the first step, right? And we take it to another website to do alignment, and we take it back to R to do the tree, and back to another website to do another tree. So it's like everywhere. So now everything is lined up in one nice workflow. So you can just click create workflow here. Done. Almost there. It's mind-blowingly simple. All right, so you have two steps here. The first step is input data. You have to input your data. So what you have to do is go back to that document, select everything that you prepare, select everything, and copy. And you go back here, and in this box here, you can just paste it. This is all your data are now in this box. This is all your sequence. Oops, sorry. All right. And then once you have that, you can leave this panel alone. This is basically all the configuration for the alignment. This is pretty good already. You don't have to do anything. But we're going to change a little bit for phi-ML here. Let's click on that. Okay, let's walk through this together, right? Interleave format, right? This is interleave. You don't have to worry about that right now because we don't use phylib. And this program is pretty good. They're gonna do auto detect whether or not it's nucleotide, nucleic acid, ATCG, or amino acid, which in this case we have nucleic acid. You can have them auto detected, or you can click on this. Either is good. And then evolutionary model, we learned about this, right? The substitution model, we have learned about GTR, Duke Cantor, K80, but because we have computing power, let's use the crazy one. Let's use GTR. Everything else is the same, so we keep everything else the same except for this. Except for the statistical test for branch support. You guys remember we talked about, We'll talk about this, right? How can we be sure that the branch is good, right? The confidence we have in the branch. Oh, thank you. I basically just teach for the whole floor, right? Right now. That's great, right? So we want to have some way to make sure that this branch is a good branch. It's actually connected to each other. So we select here, and there are a bunch of different things right now, but we're going to stick with the basic one, the bootstrap. The one, most of you guys not here when I took off my shoes and untangle everything, and it looks ridiculous. See, this is why we go to makeup class, because I tend to do ridiculous thing. Unfortunately, there's no more makeup class. So that's it. We're going to change to bootstrap, and we're going to bootstrap 100 times, just for the sake of quickness. In reality, you should do 1,000 or more, but this is for fun. So we keep everything else the same, and this is where the magic happens. You click submit and sit back and relax. Are we ready? Do we need to go back to some step? Oh, just refresh, yeah. All right, once you submit, it will go through. If you find like 500 bad requests, just refresh it and it'll come back to where you were. And this will send to what we call Galaxy user, a server. It's a server somewhere out there, supercomputer, and it's gonna take a while. And this is where it takes fun. So it walks you through all the steps that it's doing right now. So right now it's uploading content, and it's going to do the alignment for you. And look at it updating. And you can watch every step as it happens. So if I click here, the upload content, the MSA multiple sequence alignment, this is your sequence, what is sequence look like? Come on. It looks kind of funky, right? It's not aligning so well. So this is the raw sequence. So this is a raw sequence. And you go back, it should, the math alignment is already done. So you can click here. And look at that. Oh, it's aligned much more nicely now. Very good, right? So automatically, go back and see if it's done. So now it's doing the maximum likelihood trees right now. So just pray. Pray, pray, pray. Or you can pray to the new song by Bruno Mars and Rose. I can't get that song out of my head. It's so bad. Before bed. Oh, done. So this is it. We have our tree. What? Just like that, we spend the whole freaking hour understanding what the maximum likelihood is, and you telling me just one click and it's done? Almost there. All right. So the final tree is here, the 5ML new tree. So let's click on the ITO item here. This will take you to another website. And boom, this is your phylogeny, right? So the branch length here is shown different. You can see the mouse lemur is way different from the other because we use them as an outgroup, right? So if you want something is look nicer, this is all the control you can use. Things like let's 45 degree. That's ridiculous. Why would they do that? If you want to use the real branch length, you can use or ignore. So if you ignore, it will show it like this. Let's use this. And you can increase the font size, change the color. Of course, that's what we always want to do. Change the color. You can also change the color of the line here. Make the line thicker. Change the color of the line. Make it pretty. You do whatever you want. And since we use mouse lemur as an outgroup, right? We want to pull them out. So what we can do is on the line here, you do the right click. And you go to tree structure. You can say reroute the tree here. So let me zoom in. So once again, I'm gonna repeat the step. Oop, oh, what? Where? Come on. Oh no. Okay. So if you click on this, right click, or actually just do the left click is fine. Left click here and tree structure. Let me see if you could zoom in and would do for me. Okay. Tree structure, reroute the tree here. So this will make mouse lemur the outgroup. Here we go, done. Now we have the tree. What missing here is missing here is support value, right? So you can go to advanced and at the node option, you can have the internal node symbol. Oops, sorry. Wait. Not this. Wait. Why it's not the same that I see before? Give me 1 second here. Oh, sorry. What I should check is here, bootstrap or metadata right here. a branch metadata display. So you click display here, and you can choose what type of data. And this is the bootstrap support, but now it's showing as a symbol. It's a bit hard to see. We change to text. This is number, and you increase the size. So what does it say here? 61 here, right? Meaning that horse and rhinoceros are 61% together, which is, what do you think? According to our lecture, right, it should be at least what? 70% or greater. So this is pretty poor support. So we don't know if the horse and rhinos are together. But look at this. Pygmy hippo are, 74% with dolphin. So the closest relative to pygmy hippo is dolphin. What? Dolphin have no legs. But look at the tummy. There's like the same shackliness to them. So from this tree, based on cytochrome B, you found that pygmy hippo is related to bottlenose. So once you have this tree, you can just screenshot them, or you can export them to your any format you like. I like PNG because it's easy to use. And you can increase the resolution. So export this. Everything's online. Or the easier way is to do the screen capture would be okay. Come on. Done. Okay. So if you go to your download, my download folder is ugly. So you have this tree already with the transparent background. So you can use this tree for your report. That's it. That's just how easy to make the tree. Right? And if you want, so this is for the maximum likelihood. If you want to do something else, you want to do Bayesian, so we can do that. We go back to home and make a new workflow here. So let's make Bayesian tree. This is the first year I teach Bayesian tree in this class because I just found it's that easy to do. So we're gonna do math again, and now instead of 5ML, we're gonna pick Mr. Bayes and create workflow. And as usual, we select everything here, copy, and put the file here. And then we go to Mr. Bayes, and this only run for 100,000 generation. In my line of work, I use about 20 millions and above for the accuracy, but again, this is for fun. So we can leave everything be, that looks good, and we click submit. And all we have to do is sit back, relax, go get your cup of tea, go watch moving clip for inspiration, and it would automatically refresh. And you can see things as it happen. Come on. So right now, they upload the content and they're going to do the alignment again with math. This is doing it. So the more sequence you use is this process take a little bit longer. But our data set is super small, so it should be pretty easy. So for those of you who still a bit cloudy of what to do for your personal project, this could be your personal project if you want to do it. You're curious of your animal in your backyard, who they're related to, this can be done. All right, done. The tree is done. So you click here on ITO again, and this is the tree, and I'm going to increase font size. And again, mouse lemur is supposed to be outgroup, so we're going to reroute them here. And we also have to show the bootstrap support. And for Bayesian, the data to show bootstrap support is not called bootstrap, it's actually called probability. So you can show probability as a text. Increase the size a little bit. They all, and the decimal point, let's only do 2 decimal point. So the strong support should be 90% or greater. This is about 96 or 99. So Bayesian are much more confident that dolphin and pygmy hippopotamus are together. And they even confident that horse and rhino are together, 99%. So they feel pretty good about this. Even more happier than the maximum likelihood. So you can see that the relationship is quite similar across these two, but the confidence in the maximum likelihood is less than compared to the dolphin. Okay, so that's it. You can capture the screen or export. That's